Good evening, everyone. This is Mike Rosado with DevOps Live Meetup and from Dallas, Texas. Just want to give you a few ads or a few advertisements before we get started with our speaker. Just to let everybody know that DevOps Days Dallas DFW was postponed till next year, August 2022. If you didn't know it, just visit our website at devopsdays.org. But you know, there's still a lot of virtual events happening for DevOps Days. So, you know, just go out to devopsdays.org and just join any of the live events that are going to be streaming online. So don't miss out on any of those. But without further ado, I'm going to go ahead and bring on, here we go. We have Stephen Chin, and he's with JFrog. And tonight he's going to be talking to us about Singularity is here and, you know, are your deployments ready? So we'll go ahead and let him say a little bit about himself. And then if everybody can please post your questions and save them till the end of the presentation, then we'll do like a live Q&A session. But without further ado, thanks Stephen for joining us this evening.
Hey, no, thanks very much for having me. It's a pleasure to be able to speak at DevOps Live, and it's been a while since I've spoken at a group in Dallas. I know
Awesome.
the folks who run the Dallas Java user group quite well, and I've been out there, and I think I did a tour through Dallas and Austin and Houston, all kind of in one big swoop. Last time I was able to travel out there.
Yeah, definitely. We'll have to have you out sometime in the near future.
Yeah, and it sounds like your live event next year should be great as well. I'm looking forward to lots of in-person and hybrid conferences in 2022. So it should be.
Yes. Back in 2019, we had about 635 attendees. So we're hoping that it's going to be a great event this year.
No, that's gonna be awesome. So yeah, hopefully I can be out for that.
Yeah, I also want to let everybody from DevOps Live know that hopefully next month we're going to be going back to improving live. So if anybody wants to join us at improving in Plano, you know where it is. We'll post the address on the next event when it comes up. But without further ado, I'll leave you, Stephen, with this, and let me put your presentation up here.
Cool. Thanks very much.
There we go. So, thank you.
Yeah, thanks for the introduction. And I run the developer relations team at JFrog. So I've been a longtime customer of JFrog, an Artifactory user. Was doing DevOps before we even had a word for what DevOps was. So I think for a lot of folks who have been doing operations and automation and figuring out how to speed up deployments, DevOps is just the natural evolution of that. And hopefully in the presentation today, I'll teach you a little bit about what's upcoming, like different ways of thinking about the future of DevOps, and we'll have a little bit of fun. So feel free to play along with the memes, shout out in chat, and we'll have a nice discussion after the presentation about all sorts of stuff. Now, in addition, we have cool stuff for folks who are joining us for the live presentation. So you get the chance to win both the JFrog t-shirt and the Liquid Software book. So don't worry about recording or writing down stuff. All the slides will be posted, and the presentations being recorded on YouTube. So we'll post a video tube if you use that QR code to the JFrog site that we have for the event. Also, you can rate the talk on that site and enter a chat raffle for 1 of 10 t-shirts and Liquid Software book combos. So it should be a lot of fun. I looked at the meetup registration. I think folks attending have a very high chance of winning one or both of these. So make sure that you check it out and say hi to us as well. And getting to the talk, so I think when you look at our industry, just the last century has seen this tremendous acceleration in the pace of technology. I remember back when I was a kid, I was growing up on My first computer was a Commodore VIC-20, which greeted you with a nice basic prompt. In my opinion, the early computers were the best because they encouraged you to actually program and to learn how computers worked. Whereas modern computing devices, like my kids have iPads and iPhones, and in comparison, when they want to write a program or when they want to do something like actually like learn how their device works, you have to install Xcode and you have to get an Apple developer license, yada, yada, yada. There's a whole lot of ceremony as opposed to the old computers, which just showed you a basic prompt. So in my opinion, folks who grew up with all of this computing technology actually are ahead of the game because we learned how it actually works and how computers are designed and how to take them forward. And the rate of innovation, if you look at it, it's been 8,000 years between the agriculture and the industrial revolution. 120 years from the Industrial Revolution until we got the light bulb, 90 years to the moon landing, but then the web, genome sequencing, and the rapid evolution of computing power has just been in the past decade. So we're easily moving towards the place where Moore's law is applied to computers and the collective intelligence of computers exceeds that of not only small mammals, but also the human brain and the equivalent intelligence of the entire human race. So where does this, what are the conditions that are needed for this actually to take place where the computers suddenly become more intelligent than us humans? Now, the first thing is you need a lot of data. And there's actually, there is a whole lot of data. In the digital world, as of 2020, there's 6.8 times 10 to the 21st bytes. So that's a lot, exabytes worth of data, which are available to store information. And from a human perspective, we can already store all the human genome, which is 7.2 billion humans, 6.2 billion nucleotides. That's 1 times 10 to the 19th byte. So we can already store all of that information. If you count all of the Earth, that's 1.325 times 10 to the 37th. So we're not quite there, but we're getting to the point where you can basically model the planet digitally. And so the next thing is how fast are computers and technical advancements happening? And with classic computers, which are predominantly kind of single-threaded state machines, you can only get so fast. But with quantum computing and with different advances which we have in parallel computation, like tensor processing units, you get a huge increase in the collective power of computing and the ability to model problems which are NP complete and are extremely hard to solve. So the Google's tensor processing units, they released version 4, and that a cluster of version 4 TPUs will give you 1 exaflop of computational power, which is tremendous. And even quantum computing, when I first looked into this, we were up to the 60s in terms of qubits. Now we're up to 127 qubits. So quantum computing is really taking leaps and bounds forward in terms of being able to solve extremely hard problems, which help us to model and solve hard problems in AI/ML. So we have data, we have brains. The next thing we need is we need hands. We need the ability to actually do automation of technology. And an example of this is self-replicating 3D printers. So I love playing around with 3D printers. It's a great hobby project. Horrible waste of time if you want to be productive. But we're starting to come out with self-replicating 3D printers, which can print 90% of the components which make up the 3D printer itself. So that's amazing technology applied at a hobby scale. Obviously, industrial applications of this are even farther along with printing circuit boards, printing metal components. And when we get to the point where you can actually have machines replicating machines and you have full automation of technology, the computers are smarter than us, the computers know more about us than we know. I think we all know where this goes, and this is basically the same as our favorite 80s movie.
In the 21st century, our weapon will be invented like no other.
So I hope the sound's coming through. Just in case, I'll bump up the volume.
Versatile and indestructible. It can't be reasoned with. It can't be bargained with. It will feel no pity, no remorse, no pain, no fear. It will have only one purpose: to return to the present and prevent the future. This weapon will be called the Terminator.
So you can see that it's all been preordained. Skynet's coming for all of us, and it's pretty smart as well. So if you look at this, isn't that far off. So if you look at the collective growth of human intelligence versus machines, human intelligence has not been increasing very rapidly. Machines in the past, just the past 50 years, the intelligence has accelerated tremendously. And where the two lines cross here is the singularity. Although there's one little problem with this. So I modeled this with human intelligence going up, and I actually think if you look at the recent events, you'd probably want to do this and slightly adjust the line for human intelligence. So by the year 2040, we're easily looking at machines are more powerful and know more about everything than humans do. So let's take a quick glimpse into what things will look like in the year 2040 using our handy dandy Terminator time machine, adjusted slightly by the wonderful engineers at JFrog. We'll set the date to the year 2040, kick off our machine, and let's see what the future has in store for all of us. Okay, so apparently we haven't quite gotten rid of our old televisions. This is actually for those of you who have nice curved monitors where it curves around you. This is the proper curve, the opposite curve. They got this right early on in TVs with the proper curve. And clearly we can see the news report here that the United Nations has recognized the first autonomous serverless life form. So you know it's eventually when the computers get smarter than us, we will gracefully embrace our new overlords and don them as being a first-class life form. So I think this shows promise for humanity, that we're not fighting the robots, that we're embracing the robots. So this is good news. Okay, so here we have the first over-the-air update being blocked, or over-the-air update helping to block a terrorist attack. So this is awesome as well. The airline industry is probably one of the slowest in terms of embracing new technology. If you've been in an airplane recently, which you probably haven't, you see heavily outdated software systems. Even the infotainment's quite bad. But the machines can help accelerate this. And one of the challenges is pushing software updates and pushing technology to the edge. How do you get software updates on all the IoT devices, all the home automation devices? The number of devices in the world is just growing exponentially, with billions of devices that need to be updated. And if you don't update your devices, if you're not pushing updates to the edge, by the fact you're using open source software and you're using software which continually has new exploits found in it, you're putting yourself and your customers at risk. So it's good that we're finally taking the leap to update cars, to update planes, to update devices at the edge with the computing power of the new AI overlords who actually can calculate this and perfectly deploy without crashing planes. So that's great. And then the next headline, crop computing. I think we all saw this coming. Corn isn't just good for power; it's good for producing microchips and computational capabilities. So of course, this is great. If you've seen The Matrix, they're not growing humans for power; they're growing corn. So I think this is again a good sign for the future of humanity. Now, as I was saying, the number of devices out there in the world is humongous. So there's by the year 2025, there will be more than 30 billion IoT devices in the world, and this is growing exponentially. And the challenge is, how do you securely deploy and continuously update all of these devices at the edge, such as your car, your infotainment system. So if you have a smart car, you know that every couple weeks Tesla is dropping new updates to your vehicle. Your smart TV, or hopefully your smart TV's external device, because as we know, smart TVs aren't actually that smart. They get updated fairly infrequently. Cell phones have basically set the standard for continuous updates and features. So what drives expectation from consumers about expectations on software delivery velocity, a lot of this is the experience they get on their cell phone, where they're being updated continually, and you often don't even know what version of phone or software on the phone that you're running, because it's just all transparent to you, and your phone's being updated and kept secure by being connected to the network and continually getting new updates. And the last one is smart fridges, which again aren't actually that smart, but maybe in the future the robots will fix this for us. So when you want to update your device, kind of this is the thought process that we all go through. So new updates available. Do you want it? Now, if you don't want the update, you can skip or defer it. Sometimes if you do want the update, then you have to think, well, I want these new features. This is like something which as a consumer, I want to get these new features, or if I'm deploying enterprise software, I need to take advantage of new APIs, new frameworks, new capabilities. But is it risky? Maybe it's risky. Do you trust it, or do you trust the person who built the updates? And often it's not even a question of trust, because you can't trust other companies or external entities. You have to verify it. And this is where it becomes quite challenging, because there's often a costly verification to do software updates, especially with large enterprise systems. And this becomes a bottleneck in the entire software delivery process when you have the weakest link in the system, us poor humans doing software verification and trying to figure out and do quality control, figure out things work, while the robots have automated everything else around them. So we need to get out of the situation where there's a bottleneck of human intervention and fully automate the processes so it becomes seamless for us to do continuous updates, to accept new security patches, to accept new software, and to move forward the process for how we actually build software. So if you look at this from a model perspective, you want to have, of course, a continuous integration server where you're continually running builds. So hopefully you're already using something for this, like Jenkins or Circle CI or JFrog pipelines, or one of the other great CI software solutions out there. And this will help you to then release to a package management system like Artifactory, where you can store your packages securely. You can do security and vulnerability scans on it. Make sure that your binaries are entirely secure. And this helps you with quality gates as you go through different stages. So maybe first you release to an integration server. You have certain quality requirements for releasing to your integration systems, which then allow it to be upgraded to a system testing state. And again, you can do additional verifications, acceptance checks, and automated testing. If it passes that, then you go into a staging environment, which should be as close to production as possible to make sure there's no production issues, and then finally deploy to production. And ideally, all of this is automated. It's seamless. And then as you progress to different quality gates, you end up only releasing software which is stable, secure, and allows your customers to be certain that you have a secure update. And then you get to the nirvana of software delivery, where rather than asking the user if they want the updates, you just update people, because it's automated, it's seamless, it's secure. And this helps your end users, whether they're consumers or enterprise businesses, to consume the latest version of your software continually without worrying about doing costly verifications of updates, and without the humans getting in the way of the machines, which can do a much more efficient job of all of this testing. So the biggest challenge in all of this, and one of the problems this is solving, is security vulnerabilities. This basically has become the new oil spill of the 2020s, of the, what was I put us in, the 20th century? 21st? 22nd? No, 21st century. Okay, I'm bad with my centuries. But basically, when you're looking at it, vulnerabilities are one of the highest risks to modern software companies out of anything. And there's some very high-profile vulnerabilities which have happened recently, such as the Equifax data breach. So this happened a few years ago, but it's still all in our minds because it affected all of the consumers in the world. And there was an estimated $1.4 billion in cleanup costs that were associated with this security breach, and $1.38 billion in consumer claims. So this is a $1 billion security breach, which was caused by an Apache Struts vulnerability, CV 2017-5638. And this wasn't even in their main production system. This was in one of their other servers that were running some other infrastructure. They used that as a backdoor to get into the Equifax servers. They then did a few hops internally in the network to get access to the consumer database. And they had several months before this was discovered where they had time to pull data out of the network, and eventually they identified it by the data breach, tracing back the data to the server, which was compromised. And it was only a couple days once they realized that they were compromised to actually do the fix. But the end result was 143 million customers were impacted by this, and it was a multi-billion-dollar data breach. Now you're probably thinking this is back in 2017. This doesn't happen anymore, right? So just this year, the SolarWinds breach happened earlier this year, and again, this was a security breach where they got into the SolarWinds network. They got into their CI/CD server. They happened to be running Team City, but it actually wasn't the CI/CD technology which was the problem. It was the fact that the attackers got in and they were able to inject the vulnerable code between when the source was built and when the binaries were signed and delivered. So to an end user who received the hacked SolarWinds binaries, it looked like a verified release, which had been verified by SolarWinds. Because they didn't have the right security practices in place, they actually had malicious code injected into it. Those got into customers' systems, and those were used as a backdoor to then get into those customer networks and to attack their end consumers. So again, this was a huge data breach. This is what kicked off the latest round of government mandates around SBOMs, security standards. One of the best ways to get an SBOM and to build out your library of all the components is by using, again, a package management system like Artifactory, which will tell you what all your dependencies are, will give you build info on that, and can help you to avoid situations like this. Because the farther you get into production, into end state systems, the more costly it is to fix problems. So ideally, what you want to do is shift all of your security checks, your vulnerability databases, and your testing as far left as possible. If you can identify it in development because you know that you're possibly using vulnerable binaries or you've chosen libraries which are outdated, that saves you. That's the quickest switch because you can just immediately swap your third-party dependencies and then use more secure, better updated libraries. If you catch it during testing, that's still fairly easy. It has to be redeveloped, but you've caught it fairly early in the development process. If it gets all the way to staging or worst case production, then not only is it harder to fix with longer cycle times, but you're potentially exposing your customers to risk once you hit a production system, and that can be quite expensive. So the goal here is shift left with your security, shift left with your package management, and make sure that you have a secure pipeline from end to end so that exactly what you build in development is what you're testing in production. So having signed pipelines, having a secure end-to-end CI/CD, is extremely important. Okay, and I also run the partner team at JFrog, and we talked about this at SwampUp, but one of the things that we do is we build a platform for end-to-end visibility that centers around the JFrog platform. So you can integrate a bunch of different vendors like Dynatrace, Elastic, Splunk, and Datadog to give you that hybrid multi-cloud observability into your business. Tie it back in with notifications. So if you have a security vulnerability, you can get notified in your Jira or Slack. So you're shifting left and letting teams know about production issues or about potential vulnerabilities. And then even integrate with your ITSM system like PagerDuty or other IT service management systems where you can helps your production teams to better manage these incidents in an end-to-end system that supports collaboration, supports ITSM, supports observability with a platform which handles security with X-Ray, which is our security product, which handles package management and SBOMs for supply chain security, which is Artifactory, and then finally helps you to distribute to edge and support the billions of devices which we're going to need to support our robot overlords, who are going to be very happy when you're the one guy who can support all of the machines and be very efficient in running builds and have these automated processes, versus having thousands of people solving problems that the machines could better solve. So basically, by helping the robots reverse the man-machine ratio, we will be the humans who the robots rely upon. We'll be the folks who are helping the robots, and maybe we'll help our friends out as well to become better friends with the robots. Personally, I'm looking forward to the new generation where the robots take over, because we have to educate and help the young people to be friends with the robots. So this is some kids workshops, which I run together with my daughter, where we teach people how to kids and young folks how to build and do software programming using the Now robots, which are a great interaction medium for learning software development. It's also great to engage kids because they can kind of see and interact with robots, and they can learn to be friends with their new robot overlords, because as we know, the United Nations is going to accept them, and then we as humans need to accept them and then be as productive and efficient and automated as possible, so we can live harmonistically with our new robot overlords and have a bright future with the AIs of the future, who are going to help us to become even better and accelerate the pace of innovation of our entire industry. So I hope you learned a little bit about kind of where things are headed with the DevOps industry, kind of how you can accelerate your career by learning more about technologies like CI/CD, security, and help your organization to up-level what they're doing with DevOps. And if you have any questions, feel free to shout those out in the YouTube chat. As I said before, enter the raffle. I think you'll have high chances. Go to jfrog.co/DevOpsLive, and then you can win a chance of a book and t-shirt combo. We'll have 10 winners, and thank you very much for having me at DevOps Live. So this has been great to come out and virtually speak at Dallas. I hope I'm able to come out in person in the future. But even speaking virtually, I think this is a great opportunity. So thanks very much for having me.
Thank you very much, Stephen. This was a great presentation. I was very much interested on the robots. I don't know if you've seen the presentation that they did on the Olympics with the robots. Is it? I don't know if it was something similar, because they had some robots just like the one you presented there, but bigger and interacting with people and everything. It was great.
Yeah. So the parent company, which makes the Now robot I showed, so that's Aldebaran Robotics. They got bought by SoftBank, which is actually a huge Japanese software company. They're kind of a software reseller and telecommunications company.
Right.
And they have a full-size humanoid version of it called Pepper, which you'll see. Actually, they have some of them in the US as well, but you'll see them in in stores or kiosks as a way of interacting with humans. And I think the nice thing about their robots, I assume they're the ones who did the Olympics as well. I didn't see the footage, but the nice thing about their robots is they're not robots designed for machinery, not designed to do like automation. They're designed to interact with us.
Right.
And I think
that's what they were showing there, that there's a person behind the scenes with a bunch of gadgets on their hands and the heads and everything. And it was interacting with the people in the audience, and and putting emojis in their eyes and stuff like that. It was impressive.
So something they found with the research as well is for certain like medical cases and folks who have trouble interacting, like autistic patients or other folks, or sometimes the elderly. These sort of service robots are a really good way. Like kids who have trouble interacting with humans, they just
Yes.
light up, and they can really interact with robots.
Yes.
In ways which is really amazing. So I think it's great technology, and I think I'm kind of half joking about the Singularity, right? Because we're software developers, we know how stuff's built,
Right.
but I think there's a lot of potential for technology which aids humans in being more efficient and like interacting. And I think even you see the past year with COVID, there's a whole bunch of technologies which got accelerated by the need for virtual interactions, for doing things entirely online, where previously you'd have to physically go into a doctor. Now we do telemedicine. You would have to, even ordering systems for doing online ordering, food ordering, grocery ordering, all got super convenient in the past year. And this is stuff which probably would have taken another 5 years or so to really hit prime time. And it just got accelerated by the need that we have for this at present.
Right. Let's see if anybody in the audience has any questions. I haven't seen any pop up, but hopefully, I think there's only one person joined us right now. I think we're going to probably cut this one short tonight, but the presentation was great, and I'm sure that other people will watch it later that couldn't attend.
No, so they're waiting to come to your in-person event next month. Mike.
Yeah, that's what it is. That's probably right. Yeah.
So so when it works out, I'll have to come out there with one of my robots, and we'll do
sure,
an in-person presentation.
Definitely. Yeah, for sure. We'll love to have you.
Yeah, I do kids workshops too. So if you are interested, we could do some fun kids workshops too as well.
We may need to talk about that, because we have some things coming up in the pipeline with kids. So definitely have to catch up and connect on that one. Well, Stephen, thank you very much for joining us, and you have a great weekend.
Cool. Thanks so much, Mike, and appreciate you speaking at DevOps Live and to the Houston audience out there.
Thank you very much.
I mean, Dallas audience.
Yeah, for sure. You have a great one. Take care.
Thanks.